Okay, let's try to solve this count subarray. That is a nice problem for a basic. I will try to solve this question in a different way. I will use math to solve this question. And we have understood what is subarray. Okay, in the previous question that we have discussed, so you can do in C++ basic C that we have discussed this. What is subarray? Subarray is array composed from contiguous block, and here you define what does it mean subarray. 1 comma 3 would not be subarray because it is not a contiguous subsection. So here what exactly we really want to do? Okay, in the question that we have to find the number of subarray which are non-decreasing. What does it mean non-decreasing? Non-decreasing, it defines is ai is less than equal to a plus. So I can say it must be increasing, but it can be equal. So 1 2 2 3, that is non-decreasing because the equal element are always be there. What is strictly increasing? 1 2 3, that is called strictly increasing because the two adjacent elements are not equal. It is a non-decreasing and it is a strictly increasing because all the element is greater than the previous one, not equal. So equal elements are can say non-decreasing. So let's try to understand the question. So we really want to find the number of subarray which are non-decreasing. So let's try to figure out. Let's try to print all subarray first. Okay, you can write the brute force code here. Even I discussed the max subarray problem. So you can you can just find all subarray and just try to figure out like which subarray are non-decreasing. Okay, if it is not decreasing, you don't need to write, you do not to count it. Okay, I will try to use your math here. See that what does it mean? What does it mean subarray? So let's try to 1 4 2 3 5. Okay, I will pick this index I index. So can you tell me like can you tell me what are the possible of all subarray which start from this index? So first one is 1, the second is 1 4, which start with 1 1 4 2, 1 4 2 3, and then 1 4 2 3 5. Okay, that is. So this is the all subarray, all 5 subarray which start with 1. Can you tell me like what are the subarray which start with 4? It's 4 4 2 4 2 3 4 2 3 5. What are the subarray which start with 2? So I can say 2 2 3 2 3 5. What are the subarray which start with 3? So 3 3 5. What is subarray which start with 5? I can say only 5. So one thing you notice that one thing you need to notice that if the subarray is increasing, see that 1 4 is increasing. 1 4 is increasing. So 1 4 is increasing. We have a 2 subarray which are increasing. When you get here 2, which is not a non-decreasing order, okay, which is not a increasing or not decreasing order. So it will more decreasing order. So it will not subarray. So here all the subarray where with 2 encounter here, all are not good subarray. All are not valid subarray which are actually finding, which are not decreasing. Here 1 4 2 is not decreasing, 1 4 2 3. So where we find this mistake, we are just find invalid situation. All the subarray which contain these two which are not valid. So here we one thing observe that, see that 4 comma 2 is not, 4 is good, 4 is good, but I can't say 4 comma 2. 4 comma 2 is not a non-decreasing. So all the contain 4 comma 2 which is not, this is not a invalid, it is not valid. It is valid 4. And see that 2 3 5 all are increasing. 2 3 5 is all are increasing. So they see that all the increasing order. So I can say the all subarray 2 2 3 2 3 5 3 3 5 5, all are the valid situations. All are the valid subarray. So which is count. So 1 2 3 1 2 3 4 5 6 7 8 9. This is 9 subarray and that is our answer. Okay, that is the answer. So one thing you notice that this 1 4 is increasing order, this 2 3 5 is increasing order, which actually contain the all subarray which are non-decreasing, which are contain 4 2 which are not decreasing, not a increasing order. Those all of the subarray are invalid. See that 4 2 4 2 3 which are contain 4 2 4 2 all are invalid. So we really want to find how many subarrays are there which are increasing order. So here you can say that 1 comma 4 our subarray is increasing order and 2 comma 3 comma 5 subarray which are increasing order. That's 2 subarray. Okay, that is increasing order. And the what are the size of subarray? This is 2 element and the 3 element. Can I say that if the elements are 2, tell me like how many subarray can we make it with 2 elements? All the increasing. I can say 1, 1, 4 and 4. 3 elements are there. I can make it. With 2, 3, 5, if the element size is 3, how many subarray can we make it? I can say 3 element, 2 element and 1 element. So I can make the element size 3 are there. So I can make 3 plus 2 plus 1. And that is sum of n natural number. So if the subarray size is n, so I can say that is n into n plus 1 by 2, which is sum of n natural number. N into n plus 1 by 2, that is sum of n natural number. 3 plus 2 plus 1, that is the sum of n natural number till 3. So I can make the formula of sum of n natural number n into n plus 2. So we really want to find the all subarray which are increasing order or non-decreasing order, and we really want to find the size of this one. When we will get the size, we just use this formula to find the number of valid subarray. So understood this how this formula come, because if it is the element size 3, how many subarray we can make it? 3 plus 2 plus 1. See that 3 plus 2 plus 1. Okay. So let's try to code it. So here in question, we really want to find the 1 4 and 2 3 5. Okay. That is a nice question for basic purpose. So it'll count equal to 1, because always one element is always be non-decreasing. We have to check. That's why we are taking as a consider as a 1. Why are not taking 0? Because the first element is always be non-decreasing. So you don't need to check. We always check when two elements are non-decreasing or not. Okay. So I equal to 1. I will start with index 1, not 0. Because first element is non-decreasing itself, because one element is non-decreasing. If v of I is greater than equal to v of I minus 1. Okay. In the question is non-decreasing order. That's why we are equally checking the equal statement too. If it is strictly, then you don't need to check the equal statement. So if it is vi greater than equal to v of I minus 1, that means count plus plus. That means they are the increasing order, non-decreasing order. Else, when it is not, let's suppose here 2 is not greater than equal to 4, then that means what that means? What that means? That means we just found one decreasing element. Till there, we found the number of valid subarray. That is count. Okay. So here I can say one thing. So answer plus equal to count into count plus 1 divided by 2. Okay. Which is valid. Not answer is valid. And here we have to correct the count value, count equal to 1. Now count is start with 2. Okay. Then which is 3, then 5. Okay. One thing you notice, the else statement when we reach 5, 5 it is greater than equal to 3, count plus plus. So I'll just print it out. What will happen? See out count NL. Here I'll just print plus equal sign NL and see that after this loop, you can print see out count plus NL, and you can see that after checking this condition 5 greater than equal to 3, there is no else statement. So count will automatically come outside this loop and count will print here 3. Here count will print 2 equal and here 3 plus. So we really want to use formula here 2 because there's a condition there. We are not going till else statement, okay, till last. That's why you are checking this condition. So see out valid and that is our answer. See that 2 equal 3 plus. So 2 equal means this 1 4, 2 3 5 is 3. So let's try to figure out the another test case and you can easily, let's suppose so 1 1 3, then 2, these are the first 3. The size of subarray valid subarray is 3 here. Then again 2 2 3, this is again subarray valid subarray and the again is 1. This is again one subarray. So we'll print here 3 3 1 3 3 1 and we can make the all valid subarray. Okay, we can make the all valid subarray, so you can use the formula of sum of n natural number. So here 3 equal 1 plus 1 plus because this is the outside of the loop, because there is a condition at last count become 1 and it will not come in inside the else statement. That's why here it come. That's why we are making this one. Okay, so let's try to print the statement, print the output and check it out. You can do the brute force code here too. You can implement the brute force approach too. I just use a mathematics approach. What is the time complexity of this code? The time complexity of the code is big of O(n). Time complexity of this code is big of O(n). See that we have only one loops are there. We are not, and we are using the you are using the like mathematics here. So here we have only one loop, that is O of n. Okay, O of n. You can say that O of t into n. So t is a test case. So our code is accepted. Let's mark it.